Hello, how to solve this exponential problem? This is negative 29 raised to the power of n equals 29. We are solving for the values of n that satisfy this equation, so I can express this as negative 1 times 29 raised to the power of n equals 29. Now, if you have a times b raised to the power of c, this equals a power c times b power c. Applying this identity here, I'll have negative 1 power n times 29 power n equals 29. Now, if you have square root of negative 1, this equals I. If you also take the squares, output side of this will cancel this. You have negative 1 equals I power 2. So this is negative 1. I'm going to replace it with I power 2. So I'm going to have I power 2, and this is raised to the power of n times 29 raised to the power of n equals 29. Now, let's consider this identity. If you have a power c raised to the power of d, this equals a power c times d. So multiplying this out, I'm going to have I power 2n times 29 power n equals 29. So I can apply natural log. I have natural log of I power 2n times 29 power n and equals natural log of 29. Now, if you have natural log of a times b, this equals natural log of a plus natural log of b. So applying that right here, I'll have natural log of I power 2 times n plus natural log of 29 power n equals natural log of 29. Also, if you have ln of a power b, this equals b times ln a. So the 2n will come behind this. I have 2n times natural log of I plus the same thing happens here. We have n times natural log of 29 equals natural log of 29. Now there is n here. There is n here. I can factor that out. I have n times this is 2 times natural log of I plus this divide this. I have natural log of 29 equals natural log of 29. So what I can do will be to isolate this by dividing this by 2 times natural log of I plus natural log of 29 divided by 2 times natural log of I plus natural log of 29. So this cancels this. I will simply have n equals natural log of 29 divided by 2 times natural log of I plus natural log of 29. I'll leave it this way. So this is our answer based on this. I can also solve this using this other identity. There are two identities that we can easily use. This is negative 29 power n equals 29. And let's distribute this exponent. But before then, we multiply this negative 1 times 29 power n equals 29. We distribute this exponent just like what we did here. This is negative 1 power n times 29 power n equals 29. Then considering this negative 1 again, instead of making use of square root of negative 1 equals I will simply make use of e to the power of I times pi plus 1 equals 0, meaning e to the power of I times pi equals -1, right? So I'm going to replace this -1 here with this. So I have e to the power of I times pi raised to the power of n times 29 power n equals 29. Now remember, if you have a to the power of c raised to the power of d equals a power c times d, so I'm going to multiply this exponent out. I will simply have e to the power of I times pi times n times 29 power n equals 29. So what I'm going to do will be to apply natural log. I have natural log of e to the power of pi times n times 29 power n equals natural log of 29. Now, if you have natural log of a times b, this equals natural log of a plus natural log of b. Applying that here, this is my a, this is my b. So this will simply be natural log of e to the power of I times pi times n plus natural log of 29 power n equals natural log of 20. So let's apply these other properties of natural log or log. You have natural log of a power b equals b times natural log of a. That means I pi n will come behind the natural log. I'll have I times pi times n times natural log of a plus n times natural log of 29 equals natural log of 29. Now, this cancel this. I will simply have I times pi times n plus n times natural log of 29 equals natural log of 29. So from here, I can factor this out. I have n times this divide this. I have I times pi plus this divide this. I have natural log of 29 equals natural log of 29. So what I can do will be to factor or to isolate this by dividing this by I times pi plus natural log of 29. Divide this by I times pi plus natural log of 29. This cancel this. I will simply have n equals natural log of 59 divided by I times pi plus natural log of 29. So we can leave it this way as well. This is based on the identity we used here, and this other one here is based on the identity that we use here. If you observe the difference, it's just right here we have I times pi, while this other one here, we are having 2 times natural log of I. And I times pi is just like 2 times natural log of I. So this actually solidifies our solutions. The both solutions, obviously, they are correct. So there is it, depending on the identity that you choose to use. So this is how you solve these exponential problems step by step. I believe you enjoy it. Don't forget to subscribe and share. Thank you and goodbye.